Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Hi, and welcome to this new episode of the podcast. My name is Michael Schneider, and I'm working at ETAS as a senior security consultant. And as part of my job, I'm also participating in the AUTOSAR consortium. So this means my job is to increase the security of current and next-gen vehicles by supporting our customers in securing their vehicles, and also improving the AUTOSAR standard by improving security controls and adding new security controls. And today we'll talk about cybersecurity challenges in highly connected vehicles and future software-defined vehicles. And to address these challenges, AUTOSAR has now standardized a new module, the firewall module, to protect the in-vehicle network of the vehicle. And we at ETAS, we have started and led this activity. And so this was basically done by me for the AUTOSAR part and by my colleague, Siddharth Shukla, Sid, who's also on the phone. So Sid works as a senior product manager for network intrusion detection system and the firewall. And he describes himself as a product manager by job, but engineer by heart. And he's responsible for product vision, strategy, roadmap, and so on. And he acts as a customer advocate and works closely with the engineering, sales, marketing, and support department to ensure the business case and customer satisfaction goals are met. So, hi, Sid.
Hello, Mikhail. Thank you for having me here. Really excited to discuss this interesting topic with you here.
Yes, I'm also looking forward to it. So, cybersecurity challenges in highly connected vehicles. When we hear talks about highly connected vehicles, we often hear challenges for new EE architectures. I hear words like zonal EE architectures, zonal controllers, domain controllers, vehicle computers, and so on. Can you maybe give us some insights on what's behind that, and especially also with regards to the security challenges?
Definitely. So if we look into how the EE architecture is changing, so there is a profound transformation in the EE architecture, mostly driven by more and more, let's say, high end features like connectivity, ADAS, better infotainment, and a lot more. And if we look into the past, I mean, we had E architectures based on central gateways, where based on the central gateway, there were certain domains or certain regions that were connected to each other via gateway, and all the cross bus or cross zone communication happened always via the gateway. This kind of architecture was good from a security point of view. So it added up some security compared to the past, but still the performance needs were still not fulfilled there. And therefore, we started looking into more domain-centric architecture, where we started having a little bit more powerful domain controllers. And the job of domain controllers were to take care of a particular domain, like ADAS, like infotainment, could be diagnostic over IP, etc. And these domains were really taking care of the entire functionality in that area. But then we all thought of the future, and then came zonal E architecture. And with zonal E architecture, the entire concept changed. So instead of thinking about the functionality, we started thinking about the region of the vehicle. So earlier, the division in the vehicle happened based on the function it catered to. But in the zonal E architecture, it's like you divide the vehicle into zones like front left, right, rear right, and you take care of that zone itself. So with this kind of change, I mean, you get a lot of benefits out of it, like you reduce the harness weight, you reduce the length of wires in your car, and I mean, overall, it's a great benefit. but it brings in a lot of challenges. I mean, because now we are really mixing up the functionality of all the domains into a region, and the and therefore our overall, let's say, the security challenges as well as the way we route communication, everything is changing. Yeah, so that would be, I would say, a short insight into how the E architecture is changing. And then maybe one more thing is that what makes it even more challenging is that everyone is not at a same level. Like if we talk about OEMs, everyone is targeting to go to zonal E architecture. So some is moving from gateway-based architecture to zonal architecture. They are skipping one generation altogether. Some are moving from domain-based architecture to zonal E architecture. So it's very mixed up. So it's very hard to, let's say, fulfill everything in a simple way.
So if I understand you correctly, you're now saying that previously we had basically one central point, the gateway or the switch, where you could control all the security, but now it's getting more distributed because we now have this like geographical zones, and we need to take care of the in-vehicle security at different points in the vehicle. Is that right?
Definitely. So exactly what you said. So earlier it was in one region or one domain, but now everything is distributed. So I mean the functionality is distributed, and no, it's not a logical separation anymore. It's a zonal separation. So and we need to really cater to this distributed functionality needs.
What does this then mean in terms of deployment scenarios? I mean, previously we just had a switch. Now we have this domain controllers, we have vehicle computers, we have still this embedded ECUs. Where do you address security now?
So, I mean, with this challenges coming in, the security is also now going to be distributed. So you cannot rely on a central security mechanism you're using. So imagine, let's say, a very simple zonal E architecture where centrally you have 2 or 3 vehicle servers or high performance computers. Then you have 4 zones where you have zone controllers, and then at the end nodes you have small ECUs. So if I talk from a simple firewall perspective or any other security feature perspective, now you need to take care of the communication, the security of communication at the zonal level, like the zonal ECU level. You may have certain communication into the vehicle server or vehicle computers. There you need to take care of it. And in certain use cases, you may also need to cater to the end ECUs, like the end nodes on the edges, which are doing some kind of communication. So now the firewall functionality will also be completely distributed in the E architecture.
That sounds really complex. I mean,
Yes.
addressing all of these use cases like embedded ECU switches, but also like vehicle computers, that sounds very complex.
Yeah, that's very true. And actually, it was already complex before with Ethernet compared to, I mean, our experience with CAN. And with this change in E architecture, it is going to be even more complex.
So can you maybe describe the complexity and challenges a bit more? So what I see now is basically different deployment scenarios, which means in terms of different software that you need that runs on different hardware bases. You need to configure all of it. Stuff like that. What comes to your mind? What are the challenges that you're currently facing?
Yeah, so I mean, as we already talked about, I mean, just the distribution itself is challenging in general. I mean, uh, in past when we had firewall centrally, we, I mean, in real life experience, we saw challenges from time to time to communicate with different stakeholders on how the firewall rules should look like, how the configuration should look like, in what data format the communication matrix should be defined, and a lot more. But with this entire distribution in zonal E architecture at a different level, this coordination is going to be more complex. And some of the main challenges that I see is that there is no common language in which everyone can define configuration of firewall rules. So that is one major challenge. Also, when it comes to firewall, we typically classify firewalls into stateless packet filter, stateful packet filter, and deep packet inspection. And then this is the bigger classification, and under that there is a detailed set of requirements: what falls under stateful, what falls under stateless, and what falls under deep packet inspection. But this is nowhere defined in standard. Everyone has a different perception of it. So it is really, I mean, not having a common set of feature sets is also a big challenge. And then another topic that I see here is that we always talk about intrusion detection systems, and it's, I mean, how it's going to solve our problems with respect to regulations like UNECE or GBT, etc. But at the end of the day, firewall is also a sensor which is detecting some wrong messages, and it is also able to generate events. So and it can also actually act as a prevention part for from an IDS perspective. So I see a missing link from firewall to intrusion detection system.
Okay, so lots of challenges, and I think we saw these challenges some like 2 years ago when we decided that we want to uh, address these challenges and we wanted to address these in AUTOSAR, right?
Yes, definitely, and I mean we came quite far with respect to looking into the challenges and finding some potential solutions. So actually, here I would be really interested, Mickey, if you can also share why. I mean, during the standardization activity in AUTOSAR, we solved a lot of problems here, but can you explain more in detail why AUTOSAR is actually a good fit to address these challenges and not something else?
Sure. So AUTOSAR is a specification, a middleware specification that's broadly used in the automotive world. Like every vehicle that's on the road has basically running AUTOSAR on some of its ECUs. And based on this broad distribution, AUTOSAR also has this strong standardization impact. When you standardize something in AUTOSAR, it affects the complete automotive industry. So this makes it a perfect basis to address these challenges where currently requirements are maybe not diverging, but they are also not aligned. And additionally, AUTOSAR has not only the specification for software, but AUTOSAR also has RxML. And RxML is basically a description how to configure AUTOSAR. And it also takes into account the different roles that you have in the automotive market. It takes into account that there is an OEM that builds the vehicle, that has requirements towards the supplier who provides the software. And the OEM can describe its requirements and its configuration requirements into RxML and hand it over to the supplier. And this is a language, a machine language that everybody can read, that everybody can understand, and that's already used to share information and configuration between stakeholders in automotive. And I mean, you just said it. We have one challenge is this missing common language how to configure firewalls, and AUTOSAR brings with it RxML, which is already widely accepted and broadly used, and which serves as a perfect basis to address this challenge.
Yeah, so actually what you said perfectly tells us that AUTOSAR is really a good platform which can help us to solve some or most of the challenges here. So AUTOSAR actually introduced the firewall module last year for adaptive AUTOSAR and R2211 release. So can you share what it contains?
Sure. So what was introduced is a firewall, as you just said, a firewall module for adaptive AUTOSAR, which first of all covers firewall functionality, like the functionality that you have just described. So the firewall supports network packet inspection on 3 levels. So stateless network packet inspection, basically focusing on static header fields, comparing them against expected values, like IP address, for instance, or MAC address or VLAN tag. The second category would be stateful packet inspection. So this is taking into account the stateful nature of certain protocols, like TCP, for instance. And here the firewall can filter on the number of open connection, and it can ensure the state transitions, the allowed state transitions on TCP, for instance. And finally, the third category would be deep packet inspection. So the firewall can also inspect application layer protocols like some IP, like DDS, like DoIP, and perform also filtering there. And actually, there's also one more filter, that's that generic filter, so to say, which allows you to just state which byte value you would expect on a specific offset. And this allows you to basically generate arbitrary filter rules and also implement protocols that are not yet supported by the AUTOSAR firewall specification. So that's basically the main part from the functional point of view. And additionally, what was also introduced was this RxML schema. So I just said that RxML is actually the perfect basis to standardize this. And what was introduced is an AUTOSAR configuration schema that allows you to configure a firewall rule. So the firewall rule consists of a pattern. So basically you describe how should the network packet look like? What IP address do you expect? What port do you expect? What some IP service ID do you expect, for instance? And when a network packet arrives, the firewall will iterate over the defined firewall rules. And if a firewall rule matches, the firewall carries out the associated action. So it allows the network packet or it blocks it. And I think this is actually really great because now we have means to describe firewall rules, and we have a common ground for that. So the OEM can now basically just define which network packets he wants to have allowed, encode it in RxML, hand it over to the supplier reads it and can directly configure the firewall with this, and basically everything's done and no more manual work needed.
That sounds really interesting, and also the way I see it, I mean, it's this standardization of the firewall is also able to cover the complete OSI stack, like all the 7 layers. And with this generic module you talked about here, I mean, we also give a very open option to cover new protocols that have not been standardized yet. So I find it really interesting. So, I mean, we talked about adaptive AUTOSAR, but when it comes to deployment scenarios, how do we see classic AUTOSAR based ECUs as well as Ethernet switches? Because Ethernet switches are one of the, let's say, hot and popular place to run a firewall and router.
Yes, so I think we also had, you told in the beginning about different deployment scenarios for firewall. And I think we already saw there that basically we have lots of different scenarios. We have the vehicle computer that is running maybe adaptive AUTOSAR, so that is then basically already covered. But then we have also switches, and we have end nodes and domain controllers, which might be running adaptive or classic, so it depends a little bit. But in the end, all the scenarios that you've just mentioned, so classic AUTOSAR, adaptive AUTOSAR, and switches are, I think, valid scenarios. So let's first of all, period. And one of these scenarios is now covered with adaptive for the R2211 release. But when we started the concept, we already said that, look, we want to cover all deployment scenarios, which means that currently we are still working on introducing the firewall also to classic AUTOSAR, but we also want to cover the switch use case. And that's a little bit difficult because typically AUTOSAR is running on host ECUs, right? It runs on a microcontroller or microprocessor. So how can we address switches? There's currently a development that more and more smart switches are deployed. So switches that have also a programmable CPU shipped with them that allows you to run complex operations directly on the switch without having the need to give firewalls to the host. And this CPU can be used to perform advanced firewalling, like stateful firewalling or deep packet inspection, because most switches already come with some basic firewall functionality within hardware based on TCAM rules, for instance. And we said that, okay, when we have now a freely programmable CPU, we can also run AUTOSAR directly on the switch. Maybe we need to strip it down a little bit because we have really constrained resources, but we can still reuse all the AUTOSAR modules, the AUTOSAR tooling to configure the AUTOSAR stack, and also use the firewall module for classic AUTOSAR and run it directly on the switch. And this is what we've taken into account now for this release, where we are still working on currently as of today, as of time of this recording. And also taking into account the existence of hardware accelerated filtering on the switch core, such that the firewall interacts with the switch core and interacts with the TCAM rules that are available there, such that we can perform efficient filtering with parts of the network packets being inspected by the TCAM rules on the switch core, but other parts then inspected by the AUTOSAR firewall module running on the switch's CPU. And I think this gives us a good solution to also address the firewall use case on switches.
That's really good to know that we are covering all the deployment scenarios, and because if we talk about the future zonal E architecture, we will need all different deployment scenarios based on be it adaptive AUTOSAR based ECUs or vehicle computers, or really end ECUs based on classic AUTOSAR. One example could be EV charging ECU, which is quite small ECU, but the communication for charging happens over Ethernet, so it can be a good point to put a firewall, or any ECU like zonal controller or something else which is running Ethernet switch. So with this, if when the standardization activity is complete, we will be covering all the scenarios.
Yes, I think that's right. And I think that's also a good achievement, I would say, for the whole automotive industry. So coming back to the challenges that you outlined at the beginning, I think you said that what we're missing is common language, how to configure firewalls. So I would say that's a check. We have the RxML. And what's also not so clear is that we have no common requirements on the firewall because everybody has some differences. And I think here we could also address this with the standardization activity in AUTOSAR with the introduction of the firewall module. And I think the third challenge that you said was the connection to the IDS, right?
Yes, definitely. So, I mean, IDS is really, or intrusion detection system is really a hot topic in the automotive world, uh, uh, based because of two major factors. One is really the legal requirements and regulations, but also in general, you would like to make sure that you are able to stop an attack and detect an attack, not only when you are going into production or in SOP phase, but also when the vehicle is already running. So, and as I said, the firewall, from my point of view, is a component which is also supposed to generate security events if something is wrong, or it finds that some packet is not allowed. So the question was how the firewall can contribute to an efficient IDS.
Yeah. And I think here AUTOSAR also is a way to support it because AUTOSAR has the IDSM, the Intrusion Detection System Manager, that was introduced in 2020, I think, which was basically the first step of AUTOSAR to support intrusion detection systems. And the main goal is that basically you can introduce IDS sensors into the AUTOSAR modules that raise security events and report it to the IDSM. And in this sense, the firewall module is also an IDS sensor. So the firewall monitors network traffic and can raise security events to the IDSM. And the AUTOSAR Firewall module does this in case of a pattern mismatch, or if a network packet was blocked because it didn't have a rule for it to be allowed. This is an indication of somebody trying to attack the network because you didn't expect this network packet. And for this, the firewall standard has defined, I think, 18 security events that can be raised on the granularity of individual protocols. Like we have a security event for mismatch occurred on IP level, mismatch occurred on TCP level, mismatch occurred on some IP level, and so on. So basically for each protocol that the firewall supports, we have one security event that is raised to the IDSM, and then which supports you in monitoring your in-vehicle network and detecting intruders.
Mm-hmm. So I mean, that means that with help of let's say, defining the security events on the firewall side and the existing IDS manager, we are able to somehow close the loop, right? The firewall can help us, let's say, allow passing on the security events from the vehicle to the backend in some way.
Yes, I think AUTOSAR has yet the two controls available. So we have the firewall to identify the incident and the IDSM that's part of the solution to transmit it to the vehicle security operations center, to the security analyst that can identify that an attack is actually ongoing and then decide about countermeasures.
That really sounds great. I mean, we achieved quite a lot with respect to the challenges. And I mean, if we look into what we did so far, I mean, all the key challenges we talked about, be it not having a common language for configuration, we are somehow handling it with the standardization activity. We also are handling the topic of not having any common feature sets. So I think this is also something we define, and then be the connection to IDS. So with this activity, we are more or less covering all the three checkboxes. Maybe there is some more unknowns that we don't have it in the list, and it can come in future. But I think this is really going to solve a lot of problems.
Yes, I also think so. And also looking now at the bigger picture of highly connected vehicles and the software-defined vehicle, I think the firewall module is an important security control that really helps you securing modern and future vehicles. So I think this really brings us a step forward.
Yeah, I think the same, and especially the inclusion of Ethernet switch here is actually really making me more comfortable in this discussion, because every now and then I get into a discussion where we talk about these topics, and especially the challenges coming from an Ethernet switch perspective. And it's really good to have it in, because Ethernet switch is different, right, compared to standard hardware.
Yes, I'm also happy that we managed to address this topic also within the AUTOSAR standardization. Yeah, that's it. That was this episode of the podcast. So thanks for joining in, and check back soon for a new episode.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.